Hello. In this video, we're going to be taking a look at the fourth topic from your quarterly exam on Thursday, which is on finding roots algebraically. A topic we've seen applied on previous tests. Remember, roots are referring to where the function equals 0 or y equals 0. Graphically, what this looks like, we have a parabola, a rough sketch here. The roots are referring to these points right here. So remember, we can have a maximum of 2 roots for a quadratic. There's a possibility of having 1 root, and obviously it wouldn't make sense for a question like this, but there are cases where quadratic has 0 roots. Those are called imaginary. Okay, but for our purposes, we're not really dealing with any graphs. We could use that to check and things like that on the calculator. The key word here is algebraically, meaning we want to use some algebra skills, some factoring strategies, some other techniques maybe we can bring into play here. So the very first thing, what we discussed, would be setting this function equal to 0. The y-intercept, which we highlighted on the graph that I had up earlier, is where, the x-intercept is where y equals 0. So it makes sense. That's our first move. Y or b of x, replacing it with a 0. Now solving this equation, I could go about doing eyeglass and multiply the 4 out. You always want to check for a GCF. And in this case, we have one present. I have 4, 8, and 60. I could pull out a 4 and make things a lot easier on myself. If I pull out a 4, all of a sudden that intimidating trinomial now all of a sudden looks like this. Okay? And it was pretty easy to recognize 4 and 8, obviously, and also 60. Just do a quick little division on your calculator. 60 divided by 4 is 15. So 4 is a factor of all of them. If I pull it out, I get a much easier trinomial to work with. Now, I can try to factor this trinomial where a is 1. So I'm just going to start each bubble with x. And now this is going to apply my sum product rule, which is obviously a little bit easier than our eyeglass technique. So our sum product rule is referring to the b and c values. I want to find two numbers that have a sum of b, or that add up to, in this case, positive 2. And at the same time, those two numbers have to have a product, or multiply, to negative 15. Right away, use some kind of strategy here. If you know they have a negative product, you know you're dealing with one of each sign. It's the only way to get a negative answer, or negative product, right? If you multiply a positive and a negative. And always consider the product first. There's less things that multiply to 15 than there are that add to 2. So in this case, 15, I'm going to be dealing with 5 and 3. Play around with it a little bit. If it's positive 5 and negative 3, you'll get that correct sum of 2 that you want. Sometimes there is a little playing around with the numbers to settle in on your final answer. And always take an extra few seconds to verify that's correct. Because obviously that's going to mess up everything else down the line if it's not. So I plug in my two numbers of plus 5 and minus 3. And now I could utilize the zero product property. If I'm multiplying these factors together and getting 0 as an answer, one of the factors must be 0. So I'm going to find out where that happens. I'm setting this equal to 0. I'm setting this factor equal to 0. You might question what happens to the 4. You're more than welcome to set that equal to 0, but obviously nothing's going to happen there. 4 equals 0. Nothing. We're not going to get any answer out of that. So we're really concerned with the variables, in other words. Now solving these little mini equations, you probably could have done these mentally, but it doesn't hurt to write it out. You're going to get negative 5 and positive 3. So that's perfectly acceptable to leave it like that. You could write it in coordinate form if you like. Roots are at negative 5 and 3. Okay. I don't have a graphing calculator feature on my iPad, but you could certainly type in the original. Whenever you're checking something, you want to check with the original. Type in the original function. Go into your table. So you type it into y equals, then hit second graph to get that table. There's no decimals, so you're going to see these clear as day if you just scroll up and down. Next to negative 5, you should verify a 0. And next to 3, you should also see a 0. If there were a decimal answer like 0.5 or 0.25, you can adjust that in second table set and change that little delta table to whatever you want to go by. Or another feature as well would be using second trace. That's if you're getting to really crazy decimals. If you want to check a zero that way, it will work for whole numbers as well, but obviously there's easier ways to find those. Okay, so this was finding roots algebraically. Hopefully this helped clear up any issues you had, and there's a solution there. If you do have any further questions with this, be sure to let me know before Thursday, and thank you for watching.